Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable. Tonight, our Faculty Roundtable is all about the Aerospace and Mechanical Engineering Department here at the USC Viterbi School of Engineering. My name is Paul Ledesma. I'm the Executive Director of Undergraduate Admission. Here is how tonight's event is going to work. First off, I'm only going to be on for a little bit. I'm having some technical difficulties, and so I'm on my iPad. I'm looking a little weird, so I'm just saying hi, and then I'm going to get out. But I'm going to give you over to some good people here. They're going to introduce themselves, some faculty from our department. The conversation is going to be led by my colleague, Lisa Rosas, in the admission office. She'll introduce herself in a moment. And then she's going to take the whole conversation down the road of learning a little bit more about the Aerospace Mechanical Engineering Department. We're going to talk about the discipline, the curriculum, the research, everything you come to expect as a student in that program. And then towards the latter half of the session, she's going to give you a heads up. She's going to open up the Q&A. It's not open right now. So for right now, just sit back, relax, listen, be entertained. And then she's going to open up the Q&A process, and that's where you get to ask your questions. And when you ask your questions, it's going to be answered in a democratic fashion. You're all going to have the opportunity to upvote those questions to the top. So we're not going to be able to get to every question. We're only going to get to the ones that are voted most popular all the way to the top by you, that listening audience. So she'll give you another reminder before we get going into that. But Lisa, you want to introduce yourself?
Yeah. Hi, everyone. My name is Lisa Rosas. I'm the Senior Assistant Director for the Viterbi School of Engineering, and so excited to have this conversation with you guys today.
And we have three of our faculty from the Aerospace Mechanical Engineering Department. I'm going to let them introduce themselves. We'll start with the professor and the chair of the department, Professor Paul Ronney.
Actually, that's four faculty. So
Four.
Hi, I'm Paul Ronney.
Right.
I'm the professor and chair of the Aerospace Mechanical Engineering Department. Behind me there, this is Cavalier. He's my executive vice chair.
Geoff?
Hello, everybody. My name is Geoff Spedding. First of all, thank you very much for volunteering your time to come and listen to us. And we're very happy to tell you everything you want to know about the department. I teach and do research in aerospace and mechanical engineering, specializing in fluid mechanics. That includes the flow of water and the flow of air. And in the fall, I teach the Introduction to Aerospace Engineering class. So should you come here as an aerospace engineer, 9 o'clock on Monday morning, you get me. And so it's a pleasure to have you here, and I'm happy to talk further.
Saakar.
Hi, everyone. I'm Saakar Byahut. I'm a senior lecturer of Aerospace and Mechanical Engineering. This is my 5th year at USC, and I teach pretty much courses from sophomore level, junior level, senior level to graduate classes. So for me, kind of the highlight of my USC experience has been really getting to see people grow through my classes from sophomore year to when they're graduate students. I also advise two very exciting design teams on campus, the Aero Design team and the newly formed a human-powered flight research team. So feel free to look them up as well. They're on, they have their own websites. They're on Insta. They're a very exciting team. So students do some of our amazing stuff when they come to campus.
This is great.
And
well,
he won't tell you this, but he's too humble. But Saakar is the People's Choice Award for Best Professor in the department.
Thank you.
Fantastic. Very cool. And with that, I am going to stop being distracting. I'm going to get out of the way and hope you all have a great night. I can look forward to catching up with the recording after this. If you happen to miss any part of this, the recording will be on our YouTube page within a couple of days. Thanks, folks. Lisa, it's all yours.
Thanks, Paul. Okay, so for any newcomers, I want you guys to know that basically what's going to happen now is we're going to answer a series of questions, and then for the last 30 minutes, you guys are going to have the chance to send us questions, and we'll answer them as a panel. But we're going to get started with some general questions here. I think it's always really healthy to start off with, what is aerospace engineering? What is mechanical engineering? Because for a lot of our attendees here, they're not quite sure what they're interested in just yet.
Okay.
Maybe our chair should go first. Yes.
We'll start with mechanical engineering, and then Geoff and Saakar can decide who wants to answer about aerospace engineering. The way I like to explain this, as I do to Cavalier, is that mechanical engineering, if a system involves things that fly, in which case an aerospace engineer will take care of it. Okay, so that's one thing. If it involves life forms, that a biomedical engineer might take care of it, a chemical engineer, or if it involves chemical reactions, a chemical engineer may deal with it, or and so on, electrical engineering, etc. And if it doesn't involve any of those things, a mechanical engineer will do it. Oh, and if it involves any of those other things, a mechanical engineer will be involved also. Why do I say that? I say that because our core expertise in mechanical engineering includes structures, includes fluid mechanics, it includes energy and thermal systems, it involves control systems. Our core expertise is permeate, heat transfer is another one, permeates all engineered systems. And so I always say, for example, in the case of heat transfer, that heat transfer is the thing that all engineered systems, whether it's a building, whether it's a computer, whether it's a car, has issues with heat transfer. And if you don't pay attention to it, that's the thing that will come back to bite you in the end of your design process. So I like to say that what we do, our core expertise permeates all these engineered systems.
And maybe I'll have a go at aerospace engineering. So aerospace engineering concerns things that fly. There we go. There's our simple definition. But interesting things happen as soon as you leave the ground. As soon as you leave the ground, then there are two immediate prerogatives. Number one is, how do you support your weight? How do you stay up? Number two is, how do you stop from falling over? Because you don't have feet or wheels on the ground anymore. And so the third thing, when you get a little bit further from the ground, is, how do you know where you're going? And what plan are you going to make? And so we have very advanced systems in guidance and control and navigation that way precedes a lot of the autonomous systems that are tremendously fashionable these days. So very largely, aeronautical engineering concerns things with wings. When you have an atmosphere and wings work, then so do planes. And beyond that, then you need a spacecraft and rocket propulsion. And so we deal with a little bit of that also. So that's aerospace for you. If you like to look up at the sky and wonder how things get up there, then aerospace is for you.
Love it. Anything else to add?
No, I think
No.
that's
Yeah, I think that
perfect.
was clear, concise, and a perfect explanation to what the majors are. So
just
now
add-
moving on. Yeah, go
Just
ahead.
add one quick thing.
Of course.
That while Geoff teaches the Introduction to Aerospace Engineering class, I teach the Introduction to Mechanical Engineering class. So if you decide to major in mechanical engineering, you'll see me at 8 o'clock on Tuesday and Thursday mornings.
Nice.
Maybe
and
that's the reason to choose aerospace, an extra hour of sleep.
Yes, another reason.
Talking about classes, can you guys kind of describe what the curriculum is like and maybe some courses that students will be taking?
Saakar, why don't you take that one? We'll start out.
Sure. As Professor Ronney and Spedding already said, we start off your very first fall into 101 and 105, which are Intro to Mechanical or Intro to Aerospace, depending on which major you're in. And then kind of your first year is spent towards taking the math and the physics prerequisites. Your second year is when you actually start taking core engineering classes. So there's statics, there's a class on mathematical methods and programming for engineers. And then as you start getting towards your junior year, that's where you really dive into all the engineering classes. For example, sophomores that I see, they'll take flight mechanics with me. In junior year, we have an intro to lab class that kind of spans both semesters that teaches you how to do instrumentation, how to take measurements, and then how to do really cool things with those, right? And then amidst all of that, there are also core classes in fluid mechanics, thermodynamics, heat transfer, structures, that kind of stuff. And then fourth year, you'll be doing senior design projects as well as kind of going deeper into your sort of area of expertise within mechanical or aerospace engineering. So yeah, that's 4 years in a nutshell.
Let me add one thing is that from the very beginning, whether you're in 101 or 105, from the very beginning, you're going to have hands-on experiences every semester. Like in my class, I always have to bring props. The first project you work on is to build these little robot cars here that will climb a ramp, and there'll be a competitor coming up the other side of the ramp, and then you try to push each other off the top of the ramp. That's called our King of the Hill competition. And then the second project is building these 3D printed bridges. By the end of the semester, you have enough experience not just in learning about how to use computer-aided design to draw them, but also how to do stress analysis and use a stress analysis code to design the best possible bridge that meets certain specifications, weighs no more than 40 grams, has a 2-inch by 2-inch opening, spans a 9-inch gap, and you see which group's bridge can hold the most weight. And it's the same with in aerospace engineering, they built a glider, but it was too big for me to carry.
Yeah, let me show my own prop here.
Exactly.
So this week, the students in my class in 105 started building their own gliders, which they will spend the next 6 weeks building. And then at 6 o'clock on a chilly morning in November, they will have a fly-off competition to see how they perform. And by this time, we've covered enough boards with enough equations so that we can predict the performance in advance. And now we can see if the equations work. And this is a sort of familiar procedure that we go through every single year. There's a practical project. Saakar can tell you about the practical projects he has in flight mechanics. The third year is project rich. You're drowning in projects in both semesters in this infamous MECOP class, which spans 2 semesters and has you becoming functional in the lab. And I mean this in the most demeaning way possible. There's that most graduating engineers are not really functional in the lab, but ours are. And this is a very well-known fact in industry, local industry around here, and maybe further abroad, that we give a certain unique experience that always looks a little bit better in the rearview mirror, but it's a unique experience that gives you unparalleled ability to actually get jobs. And so not just jobs, but exciting and fun ones. And that comes from the liberal sprinkling of practical experience in our classes.
I
And if
love
I
that.
could add to that, yeah,
Yeah.
and if I could add to that, that sounds, I know to the students, that sounds really great, but be careful of what you wish for, because these practical hands-on classes, they take a lot of time. It takes a lot more time to build something and debug it, get it to work, to test it, and do all the reports and all that, than it is to do kind of a lecture type class where you just, have some problem sets and a couple of exams and all that. It's a lot more work, but that's the way we train our engineers from the very beginning, from the very first semester, to integrate both their hands-on experience with the classroom experience. And in particular, like, with this bridge project, you predict what the failure load will be, and then you compare it to what the experiment is, and then try to understand why they don't necessarily agree. I'm fond of saying that's where the science ends and the art begins, because we want to teach you not just the science behind engineering, but the art of engineering. Same thing, I'm sure, with the glider project. They don't always fly exactly like you thought they were going to fly.
Never.
Great. Okay, so I think this is a great transition into the research side of aerospace and mechanical engineering. Can you talk about maybe research opportunities or any research opportunities that you're involved with?
You want to go first, Paul, or?
Okay. So, you know how some kids, a lot of kids, at least my age, we always went to the stage where we like to make things burn or explode. Well, I never really grew out of that. So my main field of research is combustion. And so we say, well, what do we need to know about combustion? Haven't we been burning things for, 500,000 years? What's left to know? Well, we always want to make our engines more efficient and produce less pollution. We want to reduce the risks of fire and explosions. We all know about the tragic fires, for example, in Los Angeles and everywhere around the world that we have. Um, and how to also create even materials by these combustion processes. So there's still a lot that we want to know about combustion that we don't already know. So my research involves that. I'm primarily an experimentalist. I do work with computationalists, but I'm primarily an experimentalist. And we're funded by agencies like the Air Force, NASA, National Science Foundation, sometimes Department of Energy. And in terms of getting involved in research, I always tell students, do your homework. Don't just go to a faculty member and say, oh, what do you do? What could I do in your lab? Go to their websites, find out what they're doing, and then try to decide, okay, what am I really interested in? And then say, well, I see that you're working on, flames in confined geometries in what we call a Haley-Shaw cell. We get all these weird flow patterns. Hey, I know something about doing video processing. Maybe I could help out with that. So try to be an active participant, not a passive one, when you go talk to faculty about their research.
So I can pitch in. I do research in fluid mechanics, and most common fluids are air and water. And it's fair to say that all conscious life in the universe is life immersed in fluids, either internally or externally, or usually both. So it's extremely important to understand how these fluids work. Most of the time, we don't pay much attention because the air density around us is quite low. And so we just go our merry way walking around. And we only have to really pay attention to the fluid mechanics once we start to go fast. And of course, we're always interested in going fast. The coolest airplanes go fast. The coolest cars go fast. So what happens then? Then you must pay particular attention to the streamlining, the shape, and the design of the aerodynamic design of objects. And so one of the things that I specialize in is the aerodynamics of small-scale flying machines, things about, oh, this big. And it turns out that there's a very peculiar balance between the stabilizing forces of viscosity and the destabilizing forces coming from accelerating blobs of fluid to and fro. And we're at a sort of balancing point that can be easily disrupted. So the paradox is that the aerodynamic flows over a little wing like this are vastly more complicated than those at so-called full scale, a 737 or something like that. And of course, this is a great opportunity for an academic noodler like myself who likes to investigate weird and abstruse problems, and particularly those that involve about half a fluid mechanics textbook in just on one wing. And so one of the things we've discovered, for example, is that these sensitive flows are susceptible to disturbance by acoustic waves. That means we can buzz sound at these wings and control them. It also means that we can put the sound inside the wings, bury the speakers inside, and have them control themselves. So we have wings that sing to themselves. And in principle, they could fly with no moving parts other than the speaker diaphragms beneath the wings. Well, this work is sponsored by the Air Force, and I'm fairly careful not to tell them too much about this frivolous aspect of the work, because it would be only too easy then for an enemy to come up and blast a wing with some other noise and down it would go. But the principle is the interesting one. So how is it that you can control these sensitive flows? The other part of research that I do has to do with the hydrodynamics of underwater vehicles. And how do they work? And most particularly, whether it's true that they leave a disturbance behind underwater that can then have enough pattern and geometry to be detected remotely. Most of the reasons for having an underwater vehicle, it's a euphemism for submarine, by the way, but I won't say that S word again. Most of the reasons are that you don't want it to be detected. So if you generate a pattern that can be detected by an aircraft flying overhead with synthetic aperture radar, then you've just spent $5 billion needlessly. And so the slightly more serious point about this is that this involves basic fluid mechanics of how turbulent motion evolves within constraints. And so it's a very fun problem for us to work on. And those are two examples of the kind of stuff that we do. There are more types of research in this department. Of course, we've recently gained a lot of strength in computational mechanics, in materials, and in advanced manufacturing, in robotics. And I'm sure I'm leaving off a few, but that's my little perspective. Fluid mechanics is everything.
Great. Saakar, any research you want to add?
I am teaching faculty, so I do very, very minimal research. Some of what I'm doing right now is looking at how aircraft of the future are going to look like in terms of are they going to be electric, are they going to be hybrids? But that is kind of at higher level. Let me point out some of the other cool stuff that our faculty do. There's Professor Kwan Nguyen who does all sorts of jumping and jumping robots. So if you've seen anything come out of Boston Dynamics, for example, that's the kind of like the dog-like robots that jump and flip and all that kind of stuff. That's the kind of stuff that he works on. There's Professor Mitul Luhar who does some really cool stuff with the LA River project, where they're trying to integrate a community into the river, and he's looking at kind of the fluid dynamics of how the river interacts with the structures and how people can interact with the rivers. I am also probably leaving out some really cool stuff that other people do, but those were just two I could think of.
Oh, great. Awesome. So Students graduating from USC with an incredible aerospace or mechanical engineering degree. What are their job outcomes? What are they doing? What do they go on to do? Do you guys want to share some insight?
If I can put up a slide, I have some information about that.
Okay.
All right, so let me,
You should have access.
yeah, okay, so I want to just share this slide. Can you see that slide?
Yes.
Okay. All right. So what do our students do after graduation? You can see the numbers here. Um, you know, some go on to employment, some go on to graduate schools, few go into military service. Notice of only a very few are still seeking employment. Some take a year off to find themselves. I'm sure your parents will love that. And you say what companies they go to. You can see that at the undergraduate level, SpaceX, Boeing, Lockheed Martin, the aerospace companies, because we are, after all, in the center of the world's aerospace industry. So even a lot of our mechanical engineers go to work for the aerospace companies, and Boeing and Northrop Grumman, and also the aerospace company, which is obviously it's a sort of semi-private, semi-governmental agency that kind of oversees the Department of Defense or really the whole government activities in the aerospace sector. And you can see starting salaries here. This is this is not a misprint. This is not, they say we only had a few responses from Master of Science students, and a couple of them had really astronomical salaries. At least they reported astronomical salaries. That's why this number looks so inflated here. But normally you would see a progression of bachelor's to master's to PhD of increasing salary. This is just an anomaly for this year. But anyway, that's sort of where our students are going. And they also go to the automotive companies. We've had a number of our students who are involved in the Formula SA race car team go to work for, Honda Racing or NASCAR, or some of the other agencies that are involved in motorsports.
Very cool. I do know some students even go beyond kind of the aerospace and mechanical engineering fields as well. Can you talk about any of those students and the cool different things that they're doing?
Well, I'll say that my two best students ever in the classroom, both of these students, they took 3 of my classes and not only got the highest grade in the class in each of the 3, but just kind of blew the top off the curve in all 3 classes. And both of them now are patent attorneys. So some of our students go, that I think our degree is so versatile that not everybody, I mean, the majority still do go into an engineering profession, at least to begin with, but some of them take that in different directions.
Yeah, the outcomes of our degree can be quite diverse, and I think one of the reasons it's sensible to think about mechanical engineering and aerospace engineering is that they're good, solid, hardcore engineering degrees that are respected and looked upon with good grace by a whole range of possible employers, which include, well, law firms and include financial firms. Some of the best students I've known have also gone through the finance market and are making ridiculous amounts of money. They will certainly tilt those numbers quite a bit. Um, the purpose of education is to change the way you think and to enable you to think critically about things that you haven't necessarily been taught yet. So there's a difference between training and education. And what we do is we try to provide the latter so that you then have a springboard for a wide range of opportunities, which do exist. And this is a pretty good location to explore those possibilities too.
Yeah. So we all of our faculty will say, well, don't worry too much about the job. Worry about getting the education and the job will follow. However, everyone who ever said that has a job.
Okay, we have a couple more questions before we get to the Q&A. I'm going to ask, why should a student pick aerospace or mechanical engineering?
Oh, because it's the best degree, of course.
Not biased at all.
Yeah, no, just as I was saying, it's a genuine hardcore engineering degree. So some of it is hard, But after this, you come out with credentials that people respect and can be used for all kinds of opportunities afterwards. Mechanical engineering in particular is well known for this. And sometimes people ask the question, well, should I be in mechanical or aerospace, or should I do astro? Which of these specialities? And I have a job, so of course I'm free to offer the advice that you should just follow your passion, do what you enjoy doing. And the part of the reason for emitting that advice is that a lot of us do the same things. A lot of us uh, do the same homeworks and follow the same sets of classes. It's just what you enjoy thinking about while you're doing these 3-hour homeworks. Do you want to think about a plane? Do you want to think about a car? Do you want to think about a bridge? Do you want to think about a rocket? And I think let that guide your choice, because you'll get through your degree more easily that way. And then just to reiterate, in my humble opinion, mechanical and aerospace is the best solid choice for a core engineering class that can be then used to explode all over the map.
Yeah, and just to follow up on that, as I said, I mentioned our core expertises in structures, in fluid mechanics, and energy and thermal systems, control systems. But you also take courses, not too many, but you take some courses in materials, in chemistry. Also, you learn a lot about electronics in this Mech Ops class that was mentioned earlier, as well as programming, like even in this one of the things in building this car is it uses an Arduino microcontroller, so learn about programming, and then there are other courses beyond that. So again, that's all more on the theme of this is a broad engineering degree that you're going to get. And if you decide you want to switch to, let's just say, I don't know, electrical engineering or biomedical engineering for graduate work, you have a really solid, or even medical school, things like that, you have a really solid foundation.
Absolutely. Anything to add, Saakar?
Yeah, one more thing I'd like to add is kind of the versatility that the others pointed out, where one of the 2 students that are working in as student workers in our lab, our instructional lab, actually signed on to do a master's in electrical engineering because when they were working in lab with us, they found out that they actually liked working with circuits and breadboards and that kind of stuff. So they actually switched to EE for their master's degree and felt comfortable.
Great.
And I'm
Awesome.
sure at some point you'll talk about the PDP program. Or
Yeah, I'm
well,
not going to if someone asked, but yeah, you could talk about it, the PDP program, yeah.
okay. Well, the progressive degree program enables you to, in 5 years, get a bachelor's and master's degree. They don't have to be in the same major. Of course, you'll have to satisfy the requirements for the master's degree, switch majors as you would for your, if it's in the same major. But nevertheless, and almost half of our students do that. They spend 1 extra year to get that year of a really specialized education, because after 4 years, you probably have a pretty good idea of what direction you want to go in. And then if you can, and this is something I always recommend, again, on the theme of I already have a job, I already have degrees, I don't need any more degrees, that by doing, if you can at all possible, go through and blast through, get it all out of the way, because once you get out, into the working world, it becomes harder and harder every year to go back to school, and it takes longer. Or just like I always use the analogy, let's say, are you an athlete? Is a lot of people say, yeah. I say, well, what's your sport? Oh, basketball. Well, are you going to tell your basketball coach, coach, I think I'm going to take a few years off and then I'm going to come back? I mean, said no athlete ever, right? It's the same sort of thing. We are, in a sense, academic athletes, and so the sooner you can get through to the 4th quarter, I personally think you'll be better off that way.
Great. Yeah. Okay. Last question before we get to the students' questions. What are you excited about in the field for the next 5 to 10 years? Maybe some new advances, new projects, the future.
I'm
I
excited
can start
about
with that.
Sorry. Okay, go, Saakar.
Thank you. What I'm seeing a couple of our students doing that I advise is they're getting internships in these companies that seem to be popping up all over the place, and they design some very cool stuff like flying UAVs. So like anything as large as flying taxis to anything as small as things that deliver medicine to like remote places of the world. So some of the stuff that they're doing is very, very exciting. This new field has kind of just opened up that didn't exist, and people are putting a lot of resources into that, and that's where our students are headed. And they really enjoy the stuff that they do because they're working for smaller companies and they can contribute a lot. So I'm excited to see where this goes.
Well, you just stole my answer.
Oh no, I'm so sorry.
It's absolutely true. There's this whole ecosystem growing up in Los Angeles, so that the job possibilities are no longer restricted to the big gorillas. You don't have to work at Boeing. You don't have to work at Lockheed Martin. You don't have to work at SpaceX. There are all of these other companies, and the exciting thing is that they have realized that there are the new missions possible thanks to new possibilities in autonomy and control and materials. And so there are all these different configurations, wildly different configurations, being built and tested and touted as the next big thing. Most of them will fail, of course, but it's going to be a lot of fun to design them and see them fail and see which make it out. And so I too am very excited by the opportunities for the students to work in these basically glorified startups. Many of them, aren't they? But it's a lot of fun, and we're going to be seeing many different types of aircraft flying around in the foreseeable future.
Yeah, let me just add one quick thing to that is on the research side, but it will apply to industry as well, is obviously everybody talks about artificial intelligence, machine learning. Where I see our role as mechanical aerospace engineers is not to develop new generative AI algorithms, but how to apply them to real things. I call it the AI ML of things, just like 10 or 20 years ago, it was the whole rage was the Internet of Things. When I talk about the AI ML of things, like for example, by combining, this is a project that I'm working on, is combining machine learning with the physics. We call it physics-informed neural networks is one approach that we're using to try to be able to just take a snapshot of a flame and not just be able to say, okay, well, here's its shape and here's its propagation speed. But now we can determine, what the temperatures are, what the pressures are, what the flow field is, what the composition of the fuel and the oxygen and the combustion products are, because we know some of the physics behind it to fill in the gaps of what we can't easily measure directly. So that's kind of take a snapshot and all of a sudden you know everything there is to know about that.
Great. Awesome. Well, thank you guys so much. So those are all the general questions I have for our panel today. I did open up the Q&A for all of our attendees, and it looks like you guys saw that. You're on it, already started asking questions. So everyone else who hasn't asked a question, make sure you go in, upvote. We are going to answer based off of the most upvotes. So make sure you get in there, keep checking it as we go through these questions. So we're going to start off with the most popular one, and that right now is Sai with 13 upvotes and growing. How much programming is going to be involved, and how much prior experience should I have coming into USC Aerospace? So I'm going to start off with the second part of the question since I deal with the applications and the admission part. We don't expect you to have experience when you apply. You guys are coming in as high school students. Depending on the high school, you might not have access to these things. That's okay. There are a lot of skills that are so transferable in many different activities. All we're looking for is that you have a passion for these degrees, for this major, for these areas, and you make sure that you're reflecting that on your application. You do not need to come in as an expert. If you can get some hands-on experience in high school, that's great. You should be doing that, but don't worry if you cannot. And then I'll leave it up to you guys. The first part of the question, is there any programming involved?
Yeah, so again, looking at this, you don't have to know anything about how to build these. We'll teach you all that. We'll teach you about Arduinos. We'll teach you how to program it. We'll teach you how to build everything, how to control the motors, how to use an accelerometer to decide whether going up the ramp or on top of the ramp or falling off the ramp and then back up or turn around or whatever. That's all. I'm sure Professor Spedding's answer will be virtually the same as mine. Is, you know, it's helpful to know. What's helpful to know is, obviously to know some math, although I don't require very much math in my class, and a little bit of physics. Other than that, we're going to teach you everything you know. The course, I design it to be very, very self-contained and not expect very much any background.
I'm often asked, how much programming do you do? Often I think with the flavor that people like programming. There's a bunch of us who quite like programming. I like programming, and in parts of my life, I've spent an enormous amount of my time programming. Um, I formed a company and sold a software package and things like that. But what's really cool is when you do programming and you move physical things around, when you move motors, when you take data from the outside, when you do a little subset of robotics, perhaps, that is super. And that brings the programming and mechanical engineering and aerospace engineering to life in a way that's quite difficult to replicate.
Okay. Moving on to the next question. That was a great question, Sai. Thank you. How can applicants best convey their fit to USC's aerospace/mechanical engineering program and community in their application? This is a great question, but I do want to make sure that you guys are focusing your questions about the program today. Any application or admission related questions, we have a lot of virtual info sessions, in-person info sessions where we can answer those things. But this is learning more about the degree, the program, and what maybe your experience here could be. So let's try and focus our questions to that, but I'll go ahead and answer this. Again, just showing us where your passions are. If you're genuinely interested, tell us why, what got you into it, what would you like to do with it, things like that. And just show who you are in your answer. Be very authentic. Do not try and engineer the perfect application or the perfect response. They never read well. But just be honest in your answer. If you heard about it in a class senior year and it just sounded really cool to you, tell us. That's totally fine. Just be authentic in your response. Okay.
Yeah, if I could
Yeah, of
add
course.
something to that. The way I think of it is USC is different. I was a student at 4 different universities and on the faculty another one before coming here. And none of them really had much of a sense of family or spirit. So when I first came to USC and people were talking about this Trojan family thing, my first reaction was, okay, whatever. But I found there was really something to that. And so you should write your essays from the point of view of, as to become a member of the Trojan family, what can the family do for you? What can you do for the family? So you should look at, after you've written in those boxes based on those prompts, you say, can I copy and paste this answer into someone else's, some other university's application that has a similar prompt? If the answer is yes, it's not a good answer. So follow up on what Lisa was saying about make it real, make it personal, and make it unique to USC and what we have to offer.
I love that. Thank you. This is a reminder, go in, ask your questions about the majors, and upvote. Keep upvoting. Okay, so next question is from Idara. What would you say sets USC Mechanical Engineering program apart from other top institutions? Great question.
Well, I'll say, how about if I say one quick thing and then I'll let again, I think that the real difference is the depth and breadth of all these hand-on experiences that you get from day 1 to day N, where N is your last day here. And not just within the curriculum, but all of the extracurricular activities with the aero design team for SAE, advanced composites design team, we have a robotic combat team, all these human-powered flight. We have so many opportunities for you to actually, and a wonderful maker space where you can go and even do your own projects. So to me, it's the real product distinction is in all of these hands-on experiences.
I think that's a good answer. And I was going to shout MECOPS when I did shout MECOPS. This is the 2-semester sequence in the junior year where it's for mechanical, electrical, and optical engineering methods for the rest of us. And like I was saying earlier, it teaches you how to be functional in the lab and in the real worlds, where engineers interface with the real world. And part of that has to do with communication, also how you write a report, however long, how you write an email, how you give a 1-minute talk about your work, and so on. But I'd also like, as part of the flavor of that question, what is it that distinguishes us from some other places? I think the size of the operation is also a factor. So I teach the Intro to Aero class, as I've said for about the n-millionth time, and we have 2 sections with about 35 students in each section. And that means I can learn the students' names, and I see and meet these people on campus. And I've learned about, well, I'm probably about 70% by now. And it's the beginning of a 4-year journey that we go on together. So it's a personal experience. So at the same time, USC is a big institution with a huge football team and huge this, that, and the other. And we've got drama, and we've got music, and we've got this, that, and the other. But on the departmental level, Paul Ronney was talking about this Trojan family business, which is actually a thing. And it's a thing because all the faculty know each other, and we get to know the students too. And so it's a collaborative enterprise, if you like. And so I think there's much less chance of you getting lost in the crowd at USC than there is in some of the competitive institutions.
Yeah, so we have an AME family within the Trojan family.
Yeah, and let me also add that, you know, this whole collaborative family-like atmosphere is not just between faculty and staff. We also have very wonderful academic advisors who make our students feel heard and supported, and, you know, like they're kind of there throughout their entire journey as well. There are also, you know, like because I advise 2 design teams, the students that I see are curious, engaged, hardworking, you know, like willing to be collaborative, and they realize that engineering is a collaborative process, right? So, and part of that, part of how they are so successful also comes from the training that we give them. This class that we keep talking about, MechOps. We actually teach them how to use instrumentation, but also how to communicate effectively, right? Like how are we, so part of why one of the design teams that I advise, the aero design teams, keeps winning all these design report, best design report awards, is because they know how to communicate what they did very, very well. Not just that they build excellent planes, which they do, but they can also communicate what they did very well.
Yeah, and in fact, that at this student paper competition that we have in the Western states for the aerospace engineers, I say that every year our students come in either first and second or second and third. I say, how come we do so well in this every year? We're competing against all the top Western schools, you know, the Caltech, the UCLA, the Berkeley, Stanford, UCSD, Irvine, et cetera, et cetera. I say, how come we keep, you know, doing so well against such fierce competition? And they say one word, and that word, of course, is MechOps.
Okay, so Adi has another top voted question. What specific qualities distinguish a successful aerospace or mechanical engineering applicant at USC beyond strong academics? I'm just going to answer this real fast. Get involved, give back, leadership, things like that. We look at the whole application. So every single part, every single written element, we're looking at all of it, and we're taking into consideration you in the context of your high school. So are you taking the most rigorous courses your high school has to offer? Are you getting involved? Are you doing well? All those things. So just make sure that you're being successful in every single area of the application. The next question is also kind of, I'll just breeze through it real quick. What study abroad opportunities are there for Mech-E students? Students in just Viterbi in general can go abroad. Yes, any engineering program is typically very rigid. You do have to plan ahead. But if that's something you want to do, talk to your academic advisor. And a lot of our students have gone abroad in various different ways. Okay, great question.
And it's typically in the sophomore year, because that's the 1 year, because the junior and senior years, there's a lot of very specialized classes that you're not going to find, you know, an equivalent in Australia or in France or someplace like that. But the sophomore year, more so, there's opportunities.
Right. Okay, great job asking questions. Keep upvoting. We're going to get through as many questions as we can before our time is up today. Question from Ethan. Are the research opportunities on campus competitive, or can anyone join? That's a great question, Ethan. Anyone want to take this?
I'll have a first go. Here's the procedure to apply to do research in my wind tunnel research group. A, you do well in my intro class, and B, you come and knock on my door and ask. That's the application procedure. And of course, we can't fit 70 people into the research operation, but I do select the people who seem to be self-motivated and interested. And the procedure can be the same for any of the profs here on campus. That's why you come on campus. That's why you have in-person teaching. You knock on the door and you say who you are, what you'd like to do. And so I have currently, there are 8, 9, 10 undergraduates, something like that, in our wind tunnel research operation. And there are 3 in the lab right now as I talk. And we view that as an essential part, not essential part, but it's a very vigorous part, a very important part of the whole education. So we have the student teams, we have the research labs, and we have classes. And some balance amongst those 3 options gets you a well-rounded student who then at the end of their undergraduate career can say what they've done and show credentials to potential employers.
Yeah, and let me just add one. I agree with 100% with that. Also, keep in mind, go to professors' office hours. That is the most underutilized resource on campus. You'll never have this amount of opportunity to access to so many experts on so many things. It doesn't even have to be in engineering. If you're interested in, 18th century French literature, there's probably somebody who's an expert on Victor Hugo. Go and find us 19th century. Find out, their perspective. It doesn't have to be limited to us. Use those office hours, and not just to see how do I do problem 2B on the homework.
Okay, thank you. Next question from Katya. How would you describe the culture among aerospace students here? Is it more collaborative, competitive, or a bit of both?
I think it's overwhelmingly more collaborative than competitive. And I just read a personal statement by a student who's applying to another school, and he spent a whole paragraph describing how astonished he was that in the first 2 weeks of classes, upon receiving the first homework assignment, he found that there was a dinner being arranged where everybody was sitting around a huge table eating pizza and doing the homework assignment. And this is how students go about it. And by now, I explicitly encourage collaboration on every single homework. Ultimately, you need to be able to perform in exams and things like that. But the way of learning, the way that you can teach each other, is tremendously important. And one of the jobs of my class, I believe, is to start to form a community who will become a professional community and who will keep collaborating with each other and will keep going out to have dinner. And pretty soon I'll be going to their weddings and things like that. I've been to about 4 so far.
Yeah.
So it's quite collaborative.
Yeah, I was surprised. I came from another university. I was on the faculty at another university, what I won't name, where it was much more competitive. And, not to say in the sense of sabotaging each other, but at least in terms of people being much more siloed and working as individuals. And when I came here, I saw how students, actually work together instead of in their own little silos. I was actually quite surprised by that at first. It is competitive in the sense that the difference in the capability between the lower end of the students and the higher end of the students, right, Cavalier, is not very much. So they're just competitive in that everyone is, has very similar capabilities. But I was surprised, given that, how much they work together as opposed to in their own little silos on homeworks, on projects, studying for exams. And I can encourage that, like in my office hours, that I have it in a conference room. And so little groups will start to form. I'll be, discussing one homework problem with one group of students, and another group of students who are, already know how to do that problem or haven't gotten to it yet or whatever, will start discussing another thing. And believe me, you do not know how much, it doesn't matter how much you think you know about something, you do not understand it until you have to teach it to others. Cavalier knows that.
And I think that also extends to our student teams as well. Like last spring, for example, one of our teams had a real hard time just before their national competition where one of their vehicles broke down, and all the other teams in the design space, I heard, contributed to them, kind of like stayed late with them a couple of nights, helped them rebuild their vehicle, and went on to competition. So there's that as well. And also, every year there's a couple of senior design projects that people take on their fourth year where they need very specific expertise from, say, the rocket propulsion lab or from the air design team. And the students are very willing to teach them, like how to lay up a wing, or how to safely store and use propellants and that kind of stuff. So.
Absolutely. I work with a lot of students who post blogs on our Viterbi Admission website. If you guys ever check that out, it has a really great blog entries on the culture at USC. And that's something I think almost every student says in their why USC. It's really, really collaborative here, and they really enjoyed that aspect. Okay, thank you, Katya. Great question. Moving on to Ulysses. Are students entering mechanical or aerospace engineering required or recommended to do any preparatory coursework during the summer before freshman year? No. Once you apply, if you're admitted, we do not expect you to do anything else before. Usually your high school prep happens during high school, so enjoy the summer, take a break, relax, and then we will get into it once you enter that fall semester.
Lisa, let me just jump in real quick for
Okay,
that.
yeah.
So we do spend summers and the free time that we have talking about always revamping our curriculum and stuff. So our curriculum for both the aero and the mechie side are written so that, someone coming in, even without advanced credits or anything, can still graduate in that 4-year time period. So that's not something that you necessarily have to worry about.
Great. Okay, a reminder, we have a couple minutes left, but ask questions, upvote, get in there and upvote any questions you want answered. Matthew has the next most upvoted question. How often do upperclassmen receive internships within LA aerospace companies? That's a good question.
Very often, I would say, like Professor Spedding and I talked about, there seem to be all these companies popping up all over the place, and they are very, very keen to hire students. So our students usually don't have problems getting internships.
And if I could offer a bit of life advice, I would suggest between your freshman and sophomore year, don't worry about that internship. Do something crazy. Maybe you want to be a mountain guide, or or like my son, he's obsessed with trains, so he worked on a railroad. Your first semester, your first summer, just do something wild and crazy. After that, yeah, then it's more important to do those internships. But don't think that you have to spend your entire 4 years, right, Cavalier? Just or if you want to ride horses, do that for your first summer. Doesn't always have to be about engineering.
Absolutely. Okay, next question from Nidara. What types of aerospace or mechanical engineering research and internship opportunities are undergraduate students usually involved in?
Well, what I normally do is that I will pair up, undergraduates if I think that they're suitable with one of my PhD students and have them, and I try to have them take on a task they can call their own, not just strictly an assistant to the PhD student, but at least some little part of it that they can consider their own. And, if they contribute significantly, then, we'll include them as co-authors on the papers. I have, about, I don't know, 20 or more of my, peer-reviewed journal publications have undergraduates as co-authors based on that.
Okay. Let's see. Next, How early can students get involved in research?
In my little universe, they can get involved in research after the first semester, after they've received some education and they know the basic equations and so on.
Mhm.
So even then, sort of to echo the words that Paul Ronney was using about internships, you don't have to be doing research right away. But let's say after the first semester, you've learned a few things and maybe you can put those into practice. Maybe you've learned where the professor's doors are that you need to knock on and things like that. So I would say the earliest that you can think about getting into research is the calendar year following your enrollment in fall. So
Great. Okay. We have a couple more minutes, so we'll just try and get through as many questions as we can. Next from Adi. Adi, you've had quite a few upvoted questions. If I'm interested in both mechanical and aerospace, is it better to apply to one and later switch, or should I highlight both upfront in the application? When it comes to the application, we only consider your first choice. It does not matter to us what your second choice major is. So we typically recommend whatever interests you, but switching is usually very easy to do if you decide at some point that maybe mechanical isn't the right fit or aerospace. Anything else you guys want to add to that?
Yeah, I would say that, and I say on the first day of class, that, my role is not, this class is not a weed out class, nor is it a weed in class. We're not trying to keep you in mechanical engineering, or in Geoff's case, in aerospace engineering, if that's not for you. Our goal is to give you as accurate an understanding as possible of what the next 3.5 years will be like. So you can decide, oh yeah, this is absolutely what I want to do, or, well, nah, thank you, I'm going to try something else. And keep in mind that, you can use any of these 100 level classes to satisfy the requirement, even if you switch not just, from mechanical to aerospace or vice versa, but to another Viterbi department.
Awesome. Okay. Are there programs or clear pathways in place for students to pursue research, or should students just reach out to individual professors?
okay, here I go jumping in.
Yeah, go.
Students reach out to individual professors, but there are also programs that Viterbi runs. So there are summer research programs and programs from that that extend throughout the year. So I have about 4 or 5 students who are on some kind of fellowship with the Viterbi School for working in the research labs. And then there's a centralized resource, there's a centralized web page where prospective researchers can go and look up what labs are volunteering and what they do in those labs. And there's an application portal for that. So the two systems sit side by side, the informal knock on the door system and the slightly more formal web-based system. We use both.
Yeah, the system Curve is what a lot of students apply through, Center of Undergraduate Research for Viterbi Engineers. So if you're interested in that, you can apply. I do know that's a little bit more competitive because some students are paid to do that kind of research, and who doesn't want to get paid? Good question. Hi, Professor Rani. I heard you're interested in combustion engines for research. I was just wondering if you've considered hydrogen engines for car industry and if you're doing any research in this field. If so, how could I get involved once I arrive on campus?
Mhm. Yeah, so hydrogen is an interesting fuel. Without going into great detail here, it has 3 problems. One is safety, but that's one I think we can deal with. The second is storage. How do you store it? You have to store it as compressed gas, but the weight of the tank weighs much more than the weight of the hydrogen you can store inside the tank. And the biggest problem is hydrogen is not really a fuel. It is an energy carrier in the sense that you cannot drill a hole in the ground and out comes hydrogen. So you have to make hydrogen in most cases from something else. But anyway, getting back to your question about can you get involved? Yeah, we do research on hydrogen combustion. We have some beautiful pictures that if we had more time, I could show you of how hydrogen burns very differently because it's a very light molecule. It's very squirrely, wants to go everywhere. And so that causes flames in hydrogen to behave very differently than in any other fuel. But if you want to get involved, the thing to do is, as we've been saying, just, knock on that proverbial door and we can have a chat about it. Come to my office hours. We post when our office hours are, and just come in and have a chat. A lot of students that work in my lab just did that. They just showed up during office hours.
Awesome. Well, I think that's a great last question to end on. Before we close out today, Professors Cavalier, any final remarks for the attendees?
He's wondering when's
No,
dinner.
just thank you for attending. That's we
Yes.
really appreciate it and look forward to being able to talk further.
Yes, also thank you for spending a Friday afternoon with us. This is amazing.
Yeah. Hope to see all of you next fall.
Absolutely. Well, thank you so much. You guys will be receiving an email shortly. If you joined us late, not a problem. We will have a recording posted on our YouTube page. So you'll be receiving an email with all that information and anything that you want to refer back to. But thank you guys so much. Thank you, professors, for spending your Friday with us today. But I hope you guys have a wonderful weekend and fight on. Bye.